Hello and welcome. My name is Mark Horseman, Data Evangelist with DATAVERSITY. We would like to thank you for joining the latest installment of the monthly DATAVERSITY webinar series, Analytics Architecture with William McKnight. Today, William will be discussing standardizing data collaboration, the role of open table formats in data architecture, sponsored by Informatica. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. For questions, we will be collecting them by the Q&A section. If you would like to chat with us or chat with each other, we certainly encourage you to do so. And just to note, the Zoom chat defaults to send to just the panelists, but you may absolutely switch that to network with everyone. To find and open both the Q&A and the chat panels, you can see the icons for those features in the bottom middle of your screen. As always, we will send a follow-up email within a couple of business days containing links to the slides, a recording of this session, and any additional information requested throughout the webinar. Now let me pass it to Pritam for a word from our sponsor, Informatica. Take it away, my friend.
Hey, thanks, Mark. Thanks for having me here, and good morning, good afternoon, good evening to all of you. Let me quickly share my screen since I... Can you see my screen?
Sure can.
All right, okay. So let me... All right, okay. So hello, everyone. My name is Preetam Kumar. I'm the Director of Product Marketing, and I lead the data integration and data engineering business from a marketing perspective at Informatica. I've been with the company for more than 5 years, and this is one of the areas I'm really passionate about. Today, I'm going to cover about what is Informatica's role in open table format and for modern data architectures. So just to set up some context, the emergence of cloud had actually has changed the dynamics of the entire tech industry, wherein the storage became cheaper. The pricing model changed compared to the perpetual licensing, and also the business models have changed as well, and that accelerated a lot of new use cases, whether it is digital transformation or advanced analytics, predictive analytics, prescriptive analytics, and now you're talking about AI and Gen AI. And all this has been possible because of the flexibility, agility, and economics of what cloud provided, whether you are using infrastructure as a service, platform as a service, or software as a service here. However, the challenges and complexity still remains. In fact, it became more complex because cloud has broken the barrier. The barrier of entry has now reduced. You have now more and more applications. Earlier, you had just on-prem applications. Now you have thousands of applications that enterprises are using. In one of the studies, we found out also the data stores, the different kind of data formats, the volume of data has increased. 149 zettabytes of data are created, and they're growing at 40% every year. Now that shows the volume of data that has been going, and with the Gen AI thing coming up with the where you need a lot of unstructured data, it is even getting more and more complex. Plus the data structure and latencies. Now data is in different format, batch, real time, streaming. That is also adding to all the complexity and the fragmentations out here. So organizations started building a modern data architecture, which to address all these data challenges and also to drive their next gen use cases, whether it is generative AI or AI use cases. And to do that, as you can see here, you need end-to-end capabilities from ETL, ELT, data cataloging, quality governance, and multi-domain MDM for a 360-degree view of your data. Informatica is uniquely positioned to support all modern data architectures, whether you are using it for Lakehouse, Fabric, or or mesh architecture. We provide end-to-end data management capabilities from cataloging, engineering, application integration, powered by our CLAIRE, our AI-powered Metadata engine, deployed across any cloud, whether it's on-prem, hybrid, or serverless. Now let me get into the open table format. I know I just have only 1 minute left. So the open table format has evolved from the file formats, right, from 1998, and now you have the icebergs. In between, you had the Hadoop file system as well. Okay, and this is also provides new technology and also new challenges as well. Okay. Now let me get into this modern data warehouse architecture where we are separating the storage from the processing layer. In a typical format, you run ELT, you extract the data, transform the data, and optimize storage. What an open table format does is instead of doing an optimized storage, you can directly run the query on top of the open table format. That helps simplify you, saves a lot of cost and also storage for you guys as well. And most of the cloud data warehouse vendors are adopting it. Informatica is very much supportive of all the open table format. We have 50,000 plus connectors across different file formats, and we do support all the latest open table format like Hudi, Iceberg, and Delta Lake. And also we support any catalog storage of choice. The whole idea is to bring our simplicity to the data to your data lake and data warehousing use cases with a low code, no code tool. I encourage all of you to scan this QR code, and later on this tech would be available for you. You can click on the link wherein you can access all our open table connectors and start experimenting and using it for your use cases out here. All right, I think I finished just 1 minute about my stipulated time. Back to you, Mark and William.
Wonderful. Well, thank you so much for that great introduction. Uh, Now, let me introduce to you our speaker for this series, William McKnight. William has advised many of the world's best known organizations. His strategies form the information management plan for leading companies in numerous industries. He is a prolific author and popular keynote speaker and trainer. He has performed dozens of benchmarks on leading database, data lake, streaming, and data integration products. William is the #1 global influencer in data warehousing and master data management, and he leads McKnight Consulting Group, which has twice placed on the Incorporated 5,000 list. And with that, let me give the floor to William to get today's presentation started. Hello and
Thank you,
welcome.
Mark. Thank you, Mark. And thank you, Pritam, for sure. And welcome, everybody. We are now in session 2 of the Analytics Architecture series, a continuation of the Advanced Analytics series. So this is really the 7th year of the DATAVERSITY webinar series. I'm very much appreciative of being here. Like I was telling Mark, I kind of book in my month with these presentations and think really hard about the topic as we lead into the presentation here. And this subject dovetails really nicely with consulting that we're doing right now and have been doing pretty much in earnest for the past year or two. And people are really confused and they're really curious. And at the same time, there's been high adoption of open data formats. And so I thought I would address it here. I'm excited to do so. And this is part of, one more thing, this is part of a series of presentations we give every month. And my goal, my passion is to make great leaders of data at enterprises. And I want those great data leaders to say they got something out of these presentations. So I'm giving you everything I think you need over the course of a year in these presentations to be that great leader. So come on, tune back in. Next month, we'll have another exciting topic. But as it pertains to the role of open table formats in data architecture, as I was starting to put the topic out there and socialize it a bit that, oh, I'll be talking about this, I got a lot of questions back. Well, you're going to talk about open file formats too? And so I decided, yes, I will. I will talk about open file formats. It'll be a packed hour, but I need to do that as well because it dovetails so nicely with open table formats, and there's a lot of questions about that as well. So I had about 10 ways to go with this presentation in terms of depth versus breadth. And so what you're going to find is that I landed on talking a lot about Parquet and a lot about Iceberg. Does it mean I necessarily advocate for them? Yes, it does. But I know there's room for others as well, and I will call them out as well as we go along, and not with the same depth though. My Parquet and my Iceberg are going to be examples of open table formats and open file formats. All right, with all that, okay. This is our partial client list. This is where I learn. I learned from these clients with their great best practices that I hopefully take forward and leave behind the things that I see are not working for these clients. So I've learned a lot about many industries as a result of doing this. And these are the technologies that we deploy, a good wide range of technologies, especially in the, and I don't know what to call it anymore, but the big analytic vector mixed data management space. But data movement and APIs also much needed data management, and definitely on the operational side. And it's getting kind of hard to distinguish anymore between the analytic side, if you will, and the operational side, but we still do somewhat. So if you need any help with any of these technologies, let me know. All right, let's talk about data formats. Now, I have a relational background, as many of you do as well. And so what I think, it doesn't matter very much, but what I think is that what we're calling table formats, we should be calling file formats. And what we're calling file formats, we should be calling table formats. So please forgive me if I get them mixed up as we go along here, because that's just my relational background kicking in. Because what the table format is, and what we're going, this is what you're going to hear. The table format is a method of organizing and structuring a data set's files within a file system or object store like S3. So you got a bunch of files in S3. Okay, how do we organize those files? How do we know what tables those files belong to, and so on? We'll get into that. But file format, on the other hand, is okay. Let's just jump into the file. What's down in there? It's the physical format in which data is stored in files, such as text formats like CSV or JSON. We're not going to cover those, but they are file formats. And binary formats like Parquet, Avro, or Arrow, which we will cover. In the future, we may see file formats that are optimized for quantum bits, qubits, file formats that can efficiently store and manipulate qubits, which are the fundamental units of quantum information. But that's the future. We're not acting on that today, just putting that out there. So hopefully we're starting to see the difference between table and file format. Before we jump into the new open ones, let's look at the granddaddy of them all here, the original data format. At least it's going to be original for most everybody on this call. Definitely for me. This has been around about 40 years. The relational format, of course, is what I'm talking about. It is a data format. These new ones are not relational. They don't carry the same properties. So relational databases are exciting. We should kind of sit in awe of where it's brought us in this space. They are just that pervasive in everything that we do. Now, even if you're adopting open, doesn't mean you don't have relational around your enterprise. You most certainly do. And what it comprises is you got your page header. We'll put that aside for the moment. You've got your records. And originally, and I worked at IBM at the time doing DB2, engineering DB2. Originally, we just put all the columns in the order in which they were created. Well, databases got smarter about this as time went on, and they started to cluster up the data types, and that made sense. And it really doesn't matter what order the columns are in, as long as the metadata can tell you where the columns are. So if you do a select splat, it has to know where to go into the record and pull out the columns in the right order. So it does. There is actually a record header that prefaces the records that you see here. I didn't bother putting that on the slide, but it's there. And then you see the values for all of the columns. But the secret sauce in relational is the row IDs that sit at the end of the page. Now, the page could be 4K, could be up to 64K, perhaps even more. But these row IDs are counted from the end of the page, skip the page footer for now, from the end of the page backwards. And they contain the offset within the page of where that record begins. So if you want to know what the record is on page 123, record number 2, you go to row ID number 2, and you go to that offset, you skip the record header, and that's where everything begins. All the values begin. So it's a beautiful thing when it comes together. Let's add another record. There I added the record ID or the row ID. And there's the record, voila. And that's how it works until you fill the page up, or at least you fill it up as far as you want to fill it up. Usually you leave a little space there, because if you're clustering and you want to put another record in that fits right here, you don't want to have to move everything. So you leave a little space for that, and maybe you reorganize after a time. But that's all relational. And as good as it is, as good as this looks and may have sounded, I don't know, they have several shortcomings. including scalability limitations, an inflexible schema, struggles with large data volumes and unstructured data. Definitely unstructured data is a challenge. Data distribution, locality issues, query performance optimization challenges, and their strong consistency models can limit scalability and availability. So these limitations can lead to performance issues, increased costs, and difficulties, especially nowadays when we're trying to glean as much performance as we can out of all of our data. Relational may not be best for that, but it's still around, to be sure. But now let's move on to open table formats and open file formats. I'm going to focus on the top four of each. It doesn't mean there's not more, but these are the ones you probably have heard of. The table formats predominantly used are the Apache Hive, Iceberg, Hudi, and Delta Lake. The file format most used are Parquet, Arrow, Avro, and Orc, as well as CSV and JSON. But use the table used by the table formats to store the data onto the object. In other words, when you create the table, you identify what kind of format that you want that table to be stored in, say Parquet. And that's how it works. And then it goes into the files that are allocated to the storage for that data set as such. Table formats, again, tells how to store the files on the file systems, in which structure it stores, and file format is the way the data actually resides. An example might be using Delta Lake with Parquet files to store the data onto the file system S3. We're not getting into the S3 versus ADLS and all that stuff, but that's obviously another important component of the overall provisioning of data inside a data lake. And to be sure, we are talking about a data lake here. These are data lakes. Data lakes are on these open file formats in cloud storage. All right, the benefits. Why would you want to do such a thing? Benefits of open data formats. I think the important benefits here that I hear the most are the ones that kind of bookend this slide: interoperability and future proofing. So let's focus on those. Interoperability, that means that you have seamless data exchange. Open formats enable effortless data sharing and exchange between different tools, systems, and organizations. So you can use the less expensive storage, and you can buy your compute from your Snowflake, your Databricks, etc. Now, this avoids vendor lock-in because you can seamlessly move the data or put different compute tools on top of the data, and you're not tied to a specific vendor or tool. This gives you flexibility and freedom. So this, again, this is the number one cited benefit of open table formats that we hear about. And so you might think, oh, well, William, you must have dozens of clients that have moved and changed their compute because it's so easy to do, right? No, actually, I have none. And I've heard of some, but no, I actually don't. But they have that ability, and it makes them feel good, and it's a good thing too, because you never know what comes down the road. And we're all just so busy right now. Once we get a little bit less busy, I don't know when that's going to be, but once it becomes more of a priority, I'll put it that way, we might be doing some more shifting around of our databases to more optimal databases. And that would include needing to have interoperability. Now, we've done it in a lab environment. We have moved some Iceberg tables from Databricks to Snowflake and back and forth. And it was pretty seamless. It was certainly a lot easier than the old way of doing things, which is, okay, we've got to reformat all the data. We've got to train the new compute on the new data and all this. So didn't have to do that. Open data formats also give you flexibility and scalability. They simplify integration with various data processing frameworks, languages, and tools. There's so many tools now being created that work with Iceberg tables, for example. Open formats are developed and maintained by a community, ensuring they meet the needs of a wide range of users. I was talking with a vendor this morning who's a closed source vendor, and they're competing against open source products. And they're telling me that what they hear from their market is that there's so much value in that community, that open source community, that when they have a question, they get it answered. When they need a patch or whatever, they can get it done. And wow, that just hit home to me how valuable that collaboration community was, the open formats in the open source. Cost effective, it is cost effective. I'll show you that in a bit. And the future proofing, I guess, being able to move that data around with different tools, different compute engines, and so on. That's future proofing. Open formats help ensure that data remains accessible and usable over time, regardless of changes in technology or vendors. Of course, the hope here is that Iceberg or whatever you choose remains relevant for as long as you need it to remain relevant, for dozens of years. We will see. We will see. Relational's been around for, like I say, 40. And so we'll see if these are going to take that place. So now let's dig in to open table formats. Table format is an abstraction layer between physical data files and how they're structured to form a table. Oh, yes, tables like old relational tables. Yes, groupings of similar schema data, a way to organize and track data files in a table. Now, I'm going to talk about table formats and file formats. You also need a compute engine. You also need storage like S3. We're not covering those today, but that comprises the big four of a data lake, the big four decisions. And there are other open table formats that I'm not going to cover today, but I'll put them out there. Cassandra's mem table and how Bigtable does it with their tables. They're also important. The evolution of data storage and compute engines. Okay, Pritam took us through a little bit of this. So I'll just bring us up to 2024. Last year. It's a big deal. It's a big deal in the data world. To break it down, a database is made up of compute and storage. And historically, database companies have always sold database products with both parts combined. All the famous legacy databases are like this: Oracle, Teradata, DB2, Snowflake. Well, now they've moved away from it. I just call Snowflake a legacy. What do you know? But while that was the status quo for over 40 years, all of that has been changing recently with the embrace of open source table formats for the storage layer. This means that users of open table formats can store their data for cheap in a format that any other compute engine can query and analyze. This was the vision, the goal of Iceberg back in 2018 when it came aboard. And for several years, this was adopted by only those really, really big data companies, those advanced technology companies like Netflix, Airbnb, LinkedIn, and Apple. They used Iceberg because their data was so vast and valuable that they were hypersensitive to vendor lock-in. Well, guess what? We're all hypersensitive now to vendor lock-in. So the things that they were doing, we're now all doing in enterprises. And so because we care about that too, Iceberg is being adopted far and wide. Now, what these companies did is they used Iceberg in combination with an open source compute engine called Trino. Perhaps you've heard of it. Starburst is the Trino company today, by the way. And that forms a complete analytical data warehouse, or they sometimes called it an ice house for a while. But notice that they, meaning the Netflixes, the Airbnbs, and so on, they were not using Snowflake and Databricks. Those kinds of tools were not working with Iceberg at the time. However, in 2024, the two largest players, I've been mentioning them, Databricks and Snowflake, have both embraced Iceberg, enabling their customers to store data in this open format as well. This is huge. And this is for customers because with every major database vendor embracing Iceberg, this ushers in a new era of competition at the compute layer. Customers are no longer locked in with their platform vendor, can now shop it around. So the data lake, I've mentioned, we're talking about a data lake here today. The data lake is a set of files of structured and unstructured data. Now, we have to know somehow which tables that the files belong to. And sometimes it's multiple, but let's just assume one for now. Structured data includes columns and rows, of course. Unstructured data includes sensor data, audio files, video files. You know what I'm talking about there. A problem with traditional databases and data warehouses is that they're not designed to handle large amounts of unstructured data. And now we're all into unstructured data. We're trying to get a handle on our unstructured data more than ever. And probably in some cases more than even our structured data. Depends on the industry. But this is where the data lake comes in. It's a cheaper, large-scale storage solution that can hold all types of data. Data lakes can be built using distributed storage systems like Hadoop, well, it used to be Hadoop, or object storage systems like S3 and ADLS. However, the data lake is just a storage system, so it doesn't understand the relationships between different files or data sets. So you can't just give it this warehouse of files and say, have at it, because without any metadata describing what tables those files belong to, every query is going to have to go through every single file. And that's too much. And so we're trying to do things to it to make it more data warehouse-like. And so we have a framework that presents multiple files in the data lake as a unified table. So these files belong to table A. These files belong to table B, and so on. The concept of the table format emerges from the need to consistently identify and manage well-defined data sets. Without a table format, you'd have to manually specify which files belong to a particular data set every time that you want to run analytics. So if you have 1,000 of these, you have to list all 1,000 files every time, which can lead to errors and obviously bad performance. A table format solves this problem. The format abstraction also enables a host of other benefits. For example, you can refer to a data set by its name. We take that for granted, but it's all due to the metadata inside of Iceberg and the other table formats. So you can refer to it by name rather than a list of files. This makes it easier to work with SQL and SQL-like access tools, Python, and other data access tools. So it's important that our files be allocated to tables, and the old way of doing things was with something called folders, okay? This is back in the days of Hadoop, running analytics was a complex task. I was doing it. The data lake was a Hadoop cluster, and analytics jobs were run using MapReduce. I was doing it. However, writing MapReduce jobs requires a lot of Java code. It was time-consuming, prone to errors. There was a need to make it easier. Apache Hive was that way, okay? It provided a way to write SQL queries against the data lake, which were then transferred to MapReduce jobs. So it helped you with the development of the SQL anyway. To make it work, Hive introduced the concept of the table as a folder. This meant that a folder and its contents were treated like a single data set, with subfolders representing partitions of the table. Okay, great. Now, the limitations of this approach led to the development of more modern table formats like Iceberg, Delta Lake, and Apache Hudi. These formats take a different approach where they track the actual files that make up the table. Sounds so simple. With these modern data formats, you could always know the exact files that make up the table, and you can use statistics on those files to optimize your queries. So, for example, to understand what kind of data is in a particular file, you can understand whether you need to access it or not for a given query. And that was one of the optimizations that we got with Iceberg and the others. So a table format is a way to manage and track data sets in a data lake. It provides that standardized way to define and manage tables. Great. And next slide, here we go. Okay, now let's talk about Iceberg. Let's roll back a little bit. Tabular was the company that formed Iceberg. It was co-founded by Ryan Blue and Dan Weeks, who were actually the original creators of the Apache Iceberg table format. Big ups to Ryan and Dan. Tabular is a commercial platform built specifically to provide enterprise-grade support management for Iceberg. So they did some commercialization on top of Iceberg as a company. This company was acquired by Databricks last year. So what does that mean? I thought Databricks had its own. Well, we'll get to that. I'm not sure I know. I'm not sure anybody knows unless you work for Databricks. But anyway, I'll put the information out there. And Ryan Blue was one of the primary architects of the Iceberg table format while working at Netflix. And he continued to develop that through Tabular. And he's now part of Databricks. in Apache Iceberg, compaction. Okay, these are all the features of Iceberg. I will go through some of them, the important ones, but I'll just mention quickly that compaction is a process that Iceberg does that optimizes the storage in the table by merging multiple smaller files into larger ones. So it merges multiple smaller files into larger ones, reducing file fragmentation and metadata overhead. So it's constantly kind of in the background, doing its thing, optimizing the files. I guess that's what you need to know. It removes duplicates. It reclaims space that's no longer provisioned, and so forth. So lots of good stuff in Iceberg, which we're going to go through. Now, I'm doing a benchmark right now on the performance differences between and the cost differences between a data warehouse and a data lake. And I had hoped that I would be done with that benchmark by the time we got to this presentation. I am not done with that benchmark, unfortunately. So this is one I found that a company called Prequel did, and it highlights some of the things I'm going to be highlighting. We're going to go into a lot more, but this particular benchmark shows a TPCDS benchmark against data sets. And they used a Snowflake warehouse size of small and ran the 99 queries, US East 1 and disabled caching. Okay, native Snowflake tables were close to Iceberg in performance, though more expensive. That's not on this slide, but using external tables in Snowflake, which is kind of what you would do by default, I guess, you can see the performance was really, really off the charts bad compared to using Iceberg tables. So, and that doesn't seem to matter whether you're using an external catalog or a Snowflake catalog. So native Snowflake tables were close to Iceberg in performance, but external tables were not. And those native Snowflake tables were so much more expensive. So when you look at cost and performance, Iceberg is the way to go. So what we're doing right now, and I can leak out some of what we're finding, is we're trying to validate the benefits of a modern data lake compared to a data warehouse. It is looking like approximately 80% cost savings on incremental loads to Iceberg and or Delta Lake versus Relational. And we're doing 1.2 terabyte incremental loads. Okay, that's kind of big. We're going smaller now, so we'll have some different data points for you when this is ready. I don't expect the smaller ones are going to be up to 80% cost savings, but we'll see. Query engines can query open storage formats data with much better performance than existing external storage architectures. And there are certainly a number of obvious opportunities for more streamlined architecture and cost savings in areas like data loading, multi-engine querying, and data sharing just by leveraging Iceberg. So my statement is a modern data lake architecture with Iceberg is a most scalable, cost-effective, and performant data foundation to support analytics and AI workloads. There you go. So I'm an advocate. Some are calling Iceberg the standard now for the open data warehouse. I'm not sure I'm calling it that yet, but it's leaning in on that direction. So let's look at how it breaks down real quick. We've got a catalog. Okay, now to me, if you're not a data file, you're a metadata file. Okay, now Iceberg has layers of metadata. They have metadata of metadata, and they have metadata of metadata of metadata. That's kind of what you need to know. So there are files for those things, which they call manifest files, manifest lists, and metadata files. We're going to explore this a little bit as we go through. As you can see here, the hierarchy of things. Now, start with data files. These are the exciting files because this is where your data lives. Data files in Iceberg are the physical files that store the actual data. Each file corresponds to a subset of the table's data, of course, often determined by partitioning. So partitioning can be used to break data up into multiple data files within a table. And it also, data files also come up with a bunch of statistics about the data in them, okay? Stuff like row count, min-max values of columns, null counts, etc. And these things are fed up to the manifest files, which is a one-to-many to the data files, and we'll get to that. The statistics are used for query optimization, so you can skip files that that don't belong in the query. This describes the schema of the data in the file. In other words, the schema is in the data file as well. And schemas for tables can change over time. They don't often, but they can. And that's a big benefit of Iceberg. Iceberg supports versioning at the table level via snapshots. But a data file itself belongs to a specific snapshot. So what are those manifest files? Okay, it's metadata that lists the data files in the table snapshot. Each manifest file includes file level statistics and partition information. All the data file metadata in its data files are combined into the manifest file. So can you see how you can get a quick count of nulls or a quick count of rows or a quick min-max across the entire table from the manifest files? Hopefully you can see that. Suppose we have a table with 3 snapshots, 1, 2, and 3. All right. Each snapshot has its own manifest file. Manifest 1, 2, and 3. The manifest list file, and I'm introducing a new concept here, the list file, manifest list.json or whatever, would contain a list of the manifest files. So manifest lists are used to organize the snapshots, okay? Manifest file paths, manifest file length, snapshot IDs, partition information. This data is all in there. The schema of the table at the time the manifest was created is in the manifest file. The partitioning specification used for the data files is in the manifest file. So it helps you get appropriately into the data files. Again, this whole series, I'm trying to give you the information you need to be an excellent information architect, CDO, CTO, leader of data. And these days, those leaders know this stuff. Okay, metadata files, finally. The metadata file sits above the manifest files in the hierarchy of things, all right? And it contains a lot of information. I won't go through it all, but it tracks table schema, partition information, snapshots, and other metadata kind of information. Each time the table's modified, a new metadata file is created. So you're going to have a lot of metadata files over the course of time. So how do I create a table with Iceberg? It is so complicated. No, I'm kidding. All you do is you do your normal create table and you just say width type equals Iceberg. So that's not too hard. And that will create the Iceberg table with 4 columns. This is an album table, I guess. All right. First, the metadata file with a snapshot is created in the metadata layer. A manifest list is also created, but it isn't referencing any files yet because the table has no data. We're going to fix that in a minute. The catalog entry for the album's current metadata pointer is then updated to point to the path of the new metadata file when that happens. If I look at the resulting directory and file structure in S3, okay, after you do this, you can see this. You can see inside the schema directory, you have a new folder for the table. And then if you go into that folder, you have a metadata folder. And in there, you can see 2 files. There's the metadata and then the manifest list. All right, now let's insert some records into the table. That's got to be really complicated, right? No, it's just your normal insert statement. You already took care of the fact that it's Iceberg back when you created it. It's just simple SQL. So I'm putting in a couple records here for a couple albums. Led Zeppelin 4 was their best album. This is the SQL that I'm using in the example. And back to the iceberg diagram to see what happens when I execute this statement. So let's go back to the iceberg diagram and see what happens. A manifest file points to the data file. Okay, wonderful. A manifest list is created that points to the manifest file. This list also contains additional details and stats. And then a metadata file is created, which keeps track of the snapshots. The metadata file points to the manifest list. Finally, the value of the current metadata pointer for the table is automatically updated in the catalog to now point to the new metadata file. I now have a data folder in addition to the metadata folder. If I look inside, I can see the data file, which is in Parquet format. And if I go to the metadata folder, I have 2 JSON files, which are the 2 metadata files. Now, That's a mouthful, and here's one more arrow. Okay, that's a mouthful, and I hope I gave it justice, but I hope you can see that that is a very valuable part of Iceberg. All right, that's where all the value lies. We don't have to know in detail what happens there, but we have to know a little bit about it. Okay, none of this was available in Hive. So keep that in mind. Now, let's look at some of the feature functions of Iceberg, some of the great stuff. Snapshots. All right, when you create a snapshot, it creates a new manifest file that points to the specific data files that make up that snapshot. And snapshots enable you to do different functions on that data, like what you see there: time travel, lineage maintenance. So let's look at some of them. Schema evolution. Now, in the schema left to right here, I dropped the column state. Don't need that anymore. I added the column cashier. Okay, that's okay. That's okay. Iceberg excels in flexible and safe schema modifications through a robust metadata layer. It allows schema changes without breaking existing queries, evolving partition schemes without rewriting data. The metadata layer determines the old schema versus the new, ensuring that even old queries can access the data. Iceberg's metadata layer tracks schema changes, allowing the queries to run correctly, even with schema modifications, by adjusting how to serve the correct data based on old schemas. Now, this is partition evolution. This is a nice looking slide from iceberg.apache.org, where there is a lot of information on Iceberg. And it shows that over time, you can change your partition scheme. The data for 2008 is partitioned by month in the example. Starting from 2009, the table is going to be partitioned by day instead. Both partitioning layouts are able to coexist in the same table. So you can change your mind over time. You don't have to go back and change all the data, because you put it into that partitioning scheme for a reason, probably due to data volume. Now your volume's at a different level, and you just change the partitioning scheme, and the queries continue to operate with good query performance without it being a problem. So very efficient data management here. Time travel, part of all this, right? Time travel is made popular by Snowflake, but it's actually very interesting to people using a lot of different database solutions. The state of a table is called a snapshot in Iceberg. Previous snapshots are also called tables, just to confuse us. You can roll back to a prior version, and you can use multiple versions in a single select. And you do all this with the as of command, or keywords inside your select. There you go. This is useful for auditing, data versioning, historical analysis, data recovery, testing and development. Okay, having different data sets for testing and development, and data lineage, of course. Now, other open table formats I've drilled in on Iceberg, but there are others. Delta Lake is an open source table format developed by Databricks. I think of the Delta Lake as like data warehousing of the data lake, or the data lake house, as they call it. And we all call it that now, right? Apache Hive is a data warehousing and SQL-like query language for Hadoop. That's what it is. It's still out there, still in use. I'm not sure anything new is going on it of substance, but it's still out there. And Apache Hudi is also a pretty commonly used table format. And the choice between that and Iceberg seems to depend on the use case. Hudi is advantageous for scenarios needing real-time data updates, change data capture, and streaming data processing. Well, Iceberg is better for batch processing, data lakehouse architectures, just more solid all around, I'd say. And when complex frequent schema evolution is required without disruption. So understanding those differences is essential. Now, Iceberg's been in the news a lot. That actually may be what brought some of you here today. What's going on? Well, with the acquisition of Tabular, as I mentioned before, Databricks now has the quote-unquote brains that created Iceberg and can bring Delta Lake and Iceberg together. Are they going to? I don't know. They're leaking stuff out, and we'll see. Here's some other headlines for you. Big data vendors introduce Apache Iceberg features in the same week. So several database vendors did that. That was last year. These were all last year. headlines. The force is strong in Iceberg. Are the table format wars entering the final chapter? Ooh, how about that? AWS declares it's Iceberg all the way until customers say otherwise. I follow Lindsay Clark at the Register for good information on this subject. These come from her. Who supports what? Well, it's a moving target, but more and more, if you're in the data space, you're going to be supporting Iceberg at least. You're probably going to be supporting Data Lake. We're probably all trying to wait and see what's going to happen with the two of them. But for now, it's all guns blazing, moving into Iceberg and Delta Lake. Iceberg is now widely supported across major platforms. As you can see here, I won't go through all of them. Delta Lake got some support as well. It's gaining popularity, and customers have requested support for this. So that's why you do it. If you want to maybe lull some company customers off of Databricks, you want to have Delta Lake. By supporting that, you make it easier to switch. You can expand your ecosystem. If you're a vendor, you can expand your ecosystem by supporting Delta Lake, and you can stay relevant in the cloud era by supporting Delta Lake and not just Iceberg. And finally, there are the others that I have here for you, Hudi and Hive. Okay, and there you can see that their support's a little bit less. And I am talking here about database vendors primarily in my slides here, who supports what. Informatica supports all of them, all right, and quite well. You still need data integration in this, and Informatica is a great choice in the open data format world that we are entering. Now, a few moments on open file formats. File formats organize data in a file like a table. It keeps the schema inside, and it works with query engines. You don't have to use an open file format with an open table format. Open file formats without an open table format, well, if you do that, it's simpler, but it may lack features like schema evolution and time travel. We're not recommending that, okay? But more common is proprietary table formats with open file formats. So using proprietary table formats like those provided by cloud vendors with open file formats. So AWS Glue, Google Cloud, Big Table, etc. This can be done using things like exporting and importing CSV, JSON, or XML, utilizing APIs and different data integration tools, transforming and mapping data, and leveraging ODBC, JDBC drivers. So I don't even recommend that. So I'm recommending open table formats and open file formats. Many data management systems and big data platforms use proprietary table formats with open file formats, though. I mentioned Hive, Impala. Redshift uses a proprietary table format, but it supports Parquet and Avro. Google BigQuery. BigQuery uses a proprietary table format as well, but it supports open file formats like Avro, Parquet, and Org for data import and export. Okay, but why Parquet? Parquet is columnar, which gives you great compression. It is language agnostic, open source, of course, and supports complex data types. This goes all the way back to the column approach, which started back in 2005 with CStore. CStore. The last release of that was in 2006, but it lives on with a commercial fork in the form of Vertica. Perhaps you've heard of that. Columnar is just a way to twist the data so that relational data, that's where it started, so that there is a column or a small group of columns that are stored contiguously on storage, not the whole row. So you don't, back to my relational database page, which I showed you at the beginning, you have to IO that thing. You got to get all the columns, all 20 columns of the table. You only needed one or two for the query, like my query here, calculate the average sales for the A stores. Well, I got to get date. I got to get store number. I got to get state. I got to get category, but even if I don't care about that. Well, IO is very expensive, so we don't want to do that. We want to organize by column. And Parquet is organized by columns. Only columns of the selection and the projection are accessed, which is a beautiful thing. This is my row-based approach. We're familiar with that. All the rows stored contiguously. And vertical partitioning is column orientation, right? So each of the columns is in its own storage. And there are benefits to this. The consistent data types make it easy to compress. I'll get into a little bit of that. Resulting storage is typically far less. So you're getting way more out of your IOs when you do it this way. And let's face it, we don't want to compromise our data design by doing things that are working around the limitations of row. So in other words, if I have a table, I want all the columns of that table, all the columns that define that primary key to be there. I don't want to have to create 2 or 3 because I got to break it up because of the IO problem. I'll let the database do that with a columnar approach like Parquet. So some of the compressions are run length. It's a beautiful thing. When you have a column like quarter here, Q1, 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 etc., got a bunch of them, let's say 500 of them, you can just store the value at the start and the finish, where it finishes. You don't have to store Q1 over and over and over again. Same for Q2, Q3. Typically, you might have 1 or 2 columns of a table that are like this. So that's a beautiful thing. You can partition you can cluster it in certain ways so that the column that gets compressed is the leftmost column, is your primary part of your primary key. Yeah, beautiful thing. Dictionary encoding, which is essentially you have a map here. You have a map somewhere of value, and you don't have to store the whole thing because within a byte, which is 8 bits, right? You can store, I forget, what is it, 256 different numbers, I think. And so that's a lot of different values. As long as your cardinality is under that, you don't need to be storing the whole data value. Like United States of America, you can just store the byte and have the certain bits flipped on that represent that, cross-reference that to a map. That's a beautiful thing as well. Otherwise, you have positional representation. You have delta from median, where you're not storing, let's say you have a tight cluster of values. In other words, something like, I don't know, birth date, where we're all kind of within plus or minus 40 years of each other in the database, maybe more or less. But it's easier to store that value, that delta value, from a median value versus like a number of days or whatever, versus trying to store the whole birth date for everybody. Maybe that's not a great example, but there's lots of examples of where that's valuable. Null and trim, leading or trailing zeros or blanks, you can do that too. So these are all beautiful things about Parquet and its columnar approach. We've run many benchmarks comparing columnar to row-based, and columnar is a little slower to load, but much faster on queries. We kind of netted it out like 2.3 times faster on simple single column scans. That's pretty fast. 3.7 on simple aggregations. Oh, wow. 7.2x on analytics query with a 3-table join. Pretty common. That's a big difference there. We have to just pay a little penalty sometimes on the load. But the comparison here was Parquet versus Avro. And as you get more complex, the faster the columnar approach is going to be. Now, other file formats, Avro, it's a data serialization format. With Avro, data is serialized with a schema, enabling self-describing data and simplifying data integration. There's also Arrow, which is a cross-language development platform for in-memory data. By providing a shared memory format for data, it allows for a good data exchange between different programming languages. And what did I miss? Avro, Arrow, and of course, ORC. I talked a little bit about ORC as we were going through. It stands for Optimized Row and Columnar. So it's also columnar. Read performance, I'm going to net this out and say Parquet and ORC offer the fastest read performance, followed by Arrow. Well, Avro trails behind due to its row-based storage, as you saw. Write performance, ORC provides the fastest write performance, followed by Parquet and Avro, followed very closely by Parquet, I might add. Compression ratio, Parquet, hands down, is going to be best there. And memory usage, Arrow and Parquet have the lowest memory usage due to their columnar storage. and in-memory design, while Orc also has low memory usage, and Avro has the highest memory usage. So it kind of all depends what you want. Who supports what? Who supports Parquet? Who doesn't support Parquet? Most major data warehousing and analytics platforms support reading and writing Parquet files with varying levels of native integration, as you can see here. So find your favorite database vendor on here and see how they're doing with Parquet. It's just a matter of time before they're all supporting it fully, in my opinion. Orc, same thing. Still a matter of time before everybody supports Orc. It's a little more limited right now, but I don't think we're at the point where we can say definitively Parquet is the winner. Everybody just support Parquet and don't worry about Orc. No, I think you got to hedge your bets. You got to support Orc, and who knows what the future will bring, but Orc is strong and needed for support. And Avro and Arrow has relatively lesser support, but still strong. So if you want to hone in on a particular table format or file format, figure out who supports it and go from there. And by the way, Iceberg and Parquet are separate projects at Apache. And I was just sort of playing with the idea, well, what if they came together? What kind of power would that be? Well, that's just theoretical. It's not going to happen. And it didn't happen that way. They didn't grow up that way. And there are some reasons why they should be kept separate. So I'll leave it at that. They will be. In summary of the whole presentation now, the benefits of open data formats include interoperability, flexibility and scalability, collaboration and community, cost effectiveness, and future proofing. What got us here? The limitations of Hive's approach led to the development of Iceberg, Delta Lake, and Apache Hudi. An Iceberg table consists of multiple components: data files, manifest lists, and metadata files. Iceberg includes schema evolution, partition evolution, and time travel. We walked through that. And multiple cloud and data platforms, including AWS, Google Cloud, Azure, Snowflake, and others, support Apache Iceberg. And also, I might mention in summary to keep an eye on Databricks and what is going to happen with Iceberg and Delta Lake. And let's see how that all plays out. Parquet, on the file format side of things, it's columnar, has great compression, it's language agnostic, open source, and supports complex data types. We walked through that. And various data platforms offer support for reading and writing Parquet files. Strong support there, I would say, with some providing full native integration and others offering limited or external table support. That has been standardizing, data collaboration, the role of open table formats in data architecture. I will turn it back over to you, Mark, to see if we have any questions.
There's this one question that I just really love thinking about that got DM'd to us. So I kind of want to get both of your thoughts on this, especially from a management perspective. Under what circumstances would you switch from relational files or relational databases to open table formats? Volume, they explain, is not a volume of data is not an issue for us, but how do you ensure referential integrity in open table formats?
Okay. A couple of different questions there. I'll give it a quick one, and Pritam queue you up then. But I would say you switch when you can safely and you can safely prioritize it as an activity for the data team to do, and then you can start getting all these benefits of open file formats, which it really appears to me to be where the future is headed. So there are things that are smaller in nature, smaller data, perhaps only alphanumeric data that need to stay relational. And I get that. It's just not a priority. Maybe it's a bundled package, and that would stay with relational. So it's a judgment call over the course of time, but start to prioritize some of those migrations. When it comes to referential integrity, yeah, it's true. It's not actually handled. It's sort of the old primitive way that we have to do referential integrity. Maybe Pritam has some better ideas on this, but we've been ensuring it just through queries and checks, manual checkouts, trying to make sure that the data that gets loaded has enough integrity so that it's not going to become a problem. You have to lean in more on making sure that the data that goes in has referential integrity rather than waiting for the database to stop it. Pritam, you got some thoughts on these questions?
Yeah, thanks, William, for covering it extensively. I mean, for me, it depends on the use case, what you are looking to do. So if you're looking to run any data science use cases, maybe, I mean, you can use relational files, but open table formats, it all depends on what kind of use cases, what is your business requirement is. So that's completely up to your discretion. Regarding security from a vendor perspective, like as I was showing you, like we support all these connectors, like Hudi, Iceberg, Delta Lake. So, and there are many other open source, like we have tons of connectors wherein we can connect to different data sources. That's like out at Informatica. When we certify a connector, they're all go through all the compliances and certification, whether it's HIPAA compliant and you name it. Okay, we are totally compliant. So if you're using a vendor like Informatica in doing any of your ELT, ETL, or any kind of data management processes on all this open source tools, including Iceberg, you can rest assured that your data is secured and it is also governed as well.
Awesome, great. Well, actually, with that, that's all the time we have for today. This was an excellent presentation. So much information. Thank you, everybody, for the electric chat and Q&A as always. And have a wonderful rest of your day. We'll have a recording of the session and a copy of the slides out within a couple of business days. Have a wonderful rest of the day, everybody.
Thank you.